completing the square and using that process to solve a quadratic. All right, guys, here we go. I've brought into our screen some different examples of just the first step of completing the square. And we won't go through all of these examples, but one of the things that I want you to notice about each of these problems is you're trying to figure out what this C value is, or what the value would be that would complete the square for this trinomial. Okay, so when we think about completing the square, don't forget that completing the square actually does mean that we're completing a square. Okay, so I'm going to draw a square here, and some things we know about a square are that the dimensions on each side are equal. So whatever the dimension on this side of the square, you're going to have exactly the same dimension on this side of the square. So how that helps us out is, for example, with question number 1 right here, we're going to put the x squared term into this first box. So it's kind of like our skills with factoring. In fact, it relies a lot on our skills with factoring. And then because we need these dimensions to be exactly the same, because it's going to be a square, we're going to take this 6x that is right here, and we're going to split it exactly in half. You're going to divide it by 2. Okay, so that's going to make 3x here and 3x here. So together, that is your 6x. Okay, so if you're remembering from using the area model for factoring, what we know as we pull out common denominators here and here is that you're probably going to have a dimension of x here and x here to get your x squared. You're probably going to have a dimension of 3 times x to get your 3x here, and 3 times x to get your 3x in this space. Okay, and this is looking good so far because we know we want our measurement along one side and the other to be exactly the same. So you've done it. You've got what you need. So what is this missing value of C? This missing value of C is the part that completes the square. So here we're going to take the 3 by 3, multiply those together, and we're going to add 9. Now what that does for this particular trinomial is it changes it into an x squared plus 6x plus 9. And this trinomial is called a perfect square trinomial because it can be written as x plus 3 times x plus 3 or x plus 3 squared. And this is our goal for completing the square. Something just like that. Okay, there are a lot of examples up here that you can kind of imagine working with. Some people don't like to draw the entire box. So what they do is they'll take a problem just like this, right? To complete the square, your r squared plus 20. And the missing piece, right, this missing part that is going to complete the square is always going to be half of your b value, so you take half of it and then square it. So 20 divided by 2 is 10. 10 squared is 100. That would be the number that would complete the square. And then what you'll notice is that this could then be written as r plus 10 times r plus 10 to complete the square, or r plus 10 quantity squared. Okay? All right, so how do we use completing the square to solve a quadratic? Completing the square to solve a quadratic is going to go something like this. So I have brought in several examples. We're not going to do all of these examples. We're just going to do a couple of these examples. Okay? So we're going to start with this one right here. This one that is the a squared plus 14a minus 51. And I'm just going to write it a squared plus 14a. I'm going to get this on one side of my equal sign. I'm going to add that 51 to both sides of my equation. And so I get a plus, equals a plus 51 on this side of my equation. And I have this space for completing the square. Okay, so let's remember that completing the square, let's go ahead and draw the square on this one. That completing the square means exactly that. We're going to complete the square. I have an a squared, and I have 14. 14 is going to be divided exactly in half. Divide that bad boy exactly in half. Okay, so that must mean with the 7 divided exactly in half that we have an a plus 7 times an a plus 7, and those are our dimensions of our square. All right, so if that is the case, then that means that this box that completes the square is going to be a 7 times a 7, or a plus 49. So when you're working with an equation, what you have to do is if you add 49 to one side of your equation to complete the square, you also have to add it to the other side. Just like that. So here's what we have. We have a plus 7 times a plus 7, which we know is our squared sides, right? Which also can be written as a plus 7 squared. And over here, what is this giant number going to be? 51 plus 49 looks like it's going to be 100. So that's equal to 100. And now we're to this spot where we can continue to solve. So here comes the next step. Solving after you have completed the square. So let's do that. We worked with this a little bit already, so we're going to take the square root of both sides. We're just going to keep this blue color going here, if I can get it working. We're going to take the square root, and when we do that, don't forget that the square and the square root cancel, so we're left with a plus 7 is equal to plus and minus 10. Don't forget your plus and minus, and it's 10 because the square root of 100 is 10. And so our two answers are going to come from a plus 7 equals a positive 10, and a plus 7 equals a negative 10. So as you continue to solve here, subtract 7 from both sides, we get a is equal to 3. Subtract 7 on this side. We get a is equal to a negative 17. And these are your two solutions to that problem of solving and completing the square. All right, I'm going to stop this video here. I'd like you guys to try some on your own. Maybe you try a couple of these. Go ahead and try 5 and maybe 6 here, right? Remember to move this to the other side of the equal sign first as you're getting ready to solve. And in the next video, I think what I'll do is I'll go ahead and show you how to do numbers 5 and 6. And I'll also show you how to do one that's a little bit trickier if we do have a leading coefficient here that is not equal to 1. All right, guys, try these. It's great practice to try something on your own first and then watch somebody do it. So I encourage you to do that, and I will see you in our next video, part 2.